Hello, this is Phil Barletta, Director of Operations of the NC State Nanofabrication Facility. I'm here to talk about my Power America project dealing with the short course focused on wide bandgap semiconductors and power devices. The NNF, along with NC State's Analytical Instrumentation Facility, which is a characterization facility on campus, is being supported by Power America to run a multi-day short course focused on wide bandgap power devices. The target participants for this short course are professional engineers and technicians, as well as students and postdocs. Session 1 was held live in December, while Session 2 is being held virtually because of the COVID-19 pandemic. NNF and AIF are very well suited to do this type of course because of their participation in RTNN. RTNN is the Research Triangle Nanotechnology Network, which is one of the 16 NSF-funded National Nanotechnology Coordinated Infrastructure sites. And the role of RTNN is to enhance access to university resources by overcoming common barriers such as awareness, cost, and distance. What this means is RTNN participates very frequently in a lot of different types of educational activities, such as the short course for Power America. A review of Session 1 is below. Session 1 of the short course, as I mentioned earlier, was held live on campus December 4th, 5th, 2019, and there were 6 participants, 5 from industry and 1 student. NCSU professor and Power America CTO Victor Valiatis delivered the keynote seminar, and a number of NCSU faculty and staff also gave lectures explaining power devices, materials, and fabrication, and hands-on demonstration of power device fab and test was successful. This means that the participants actually suited up and went into the clean room and were given tours of this clean room and got to put their hands on the equipment. They're also given tours and hands-on demonstrations of all the characterization techniques such as microscopy and X-ray diffraction, and also got to see a power device being tested with big thanks for Spiros Pavlidis for giving the help in that. Here are some of the photos for Session 1. You can see the participants actually being suited up in the clean room, seeing things such as atomic layer deposition, metallization, lithography, plasma etch. And you could also see them in some of these photos in AIF, the Analytical Instrumentation Facility, where they got to see things like electron microscopy and X-ray diffraction. In the upper right, you can see Professor Valiatis delivering the keynote seminar where he talked about the present, past, and future of wide bandgap semiconductors. Session 1 of the short course was very well received by the participants. They really liked the hands-on portion of the short course, particularly being able to actually go into the fabs and the testing labs to see how the devices are being made, characterized, and tested. Session 2, as I mentioned earlier, is going to be held virtually, and it's actually being held concurrent with this Power America summer session. There'll be lecture-style presentations, also virtual lab tours and demos, and for this virtual session we also decided to bring in an expert panel on the first 2 days along with the keynote on day 3. The virtual session will also have a section dedicated to semiconductor packaging, which was one of the things which was missing from the short course in Session 1. And as of July 27th, we've had more than 150 participants signed up, so we expect to have a really big turnout. For the expert panel, we reached out to folks in academia, in industry, and in government to come in and help describe their expertise in power devices. And the keynote will be delivered by Professor Balaga from NC State. The keynote speech will be entitled Silicon Carbide Power Devices, a 35-year journey from concept to commercialization.